Good morning children. Today we are going to see one more compound of nitrogen, nitric acid, HNO3. It is prepared by different methods. Let me see two methods in this. The first one is laboratory method. In this laboratory method we take two salts, one is sodium nitrate or potassium nitrate, NaNO3, KNO3. This will be added with what? Concentrated H2SO4 and heated. On heating, what happens? You are going to get HNO3. Very simple to write the reaction. Take NaNO3, take H2SO4. From this, you add H plus to this one. Just add what happened? Hydrogen, H plus to this one. Definitely we get what here? In the place of this one, what we get here? HNO3. In the place of what we get here? Sodium actually. So in this way, we can easily remember the reaction. In the place of hydrogen, we get sodium. In the place of sodium, we get the hydrogen here. Next, Oswald process. In Oswald process, what happened? We'll take three steps. The first step is what? By using the catalyst. Here, catalyst we use platinum or rhodium we can take here. Platinum or rhodium we can take here. So in the catalytic oxidation, what happens here? Ammonia undergo oxidation in presence of the catalyst here. Isn't it? These are all what gas molecules. They are all what gas molecules. The obtained one also what here? Gas molecule. Now in the enthalpy of this reaction, if you observe, that is 19.2. That is not very important for us. But here what is happening here? Ammonia undergoing oxidation to give nitric oxide. This is very important for us. What you are getting here? Nitric oxide you are getting actually. You are getting what here? Nitric oxide. Oxidation of ammonia produce nitric oxide. See, actually here also the balancing is very simple for us. The oxidation state of nitrogen is -3. In this case it is +2. How many electrons are exchanged here? In the case of this one, 5 electrons. Next, oxygen here, 0 oxidation state. In the case of this one, oxidation state will be what here? Oxide, -2. How many electrons are exchanged in the case of 0 to 2 or 2 electrons, isn't it? But how many oxygens are there? Generally, for example, if I don't balance here, just if I remove this one, how many electrons are there here? 2. 2 to the what? 4. Now, for this one, 4 electrons are exchanging. For this one, 5 electrons are exchanging. Cross method, this will get 4 and this will get here what? 5 actually, because here 4 electrons, here 5 electrons. So you will get 4, it will get 5. It is very easy to remember here. Next, oxidation of nitric oxide. So next, further oxidation takes place. Nitric oxide again react with X amount of oxygen to convert into nitrogen dioxide. This is an equilibrium reaction. And finally, absorption tower. In absorption tower, what happens? We spray the water on nitrogen dioxide. So immediately nitrogen dioxide will convert into nitric acid plus again nitric oxide we are going to get. Nitric oxide we are going to get. Again this nitric oxide will be recycled. Here it will be recycled. Again we are going to get further nitric acid. This is the preparation method for what? Nitric acid here. Next, in continuation to that one, we will take a concentration of HNO3, how to make because it is a dilute HNO3. The formed one is a dilute HNO3, so we need to concentrate that one. But initially we use distillation method. So both water and nitric acid undergo distillation. So once if we do distillation, the concentration will convert into 68%. Then if you want 98% of HNO3, we need to take concentrated H2SO4. Generally it is a dehydrating agent which removes the water from wherever water present in the concentrated HNO3. It will remove the water. So by dehydration of water from the HNO3 by using sulfuric acid, we get here 98% actually. Next we will see the physical properties. Generally when you observe the HNO3, generally it is a colorless liquid. But when you observe in the bottle, what happens? It will exhibit some yellow color, some pale yellow color it will exhibit. some pale yellow color it will exhibit. So, what is the reason? You may get a question, why HNO3 even if it is a colorless exhibiting pale yellow color, what is the reason? So, in this case very simple, we have some nitrogen dioxide impurities will be there. Otherwise what happen, whatever water will be there around the HNO3 that may undergo reaction to convert into nitrogen dioxide. So, the impurities of nitrogen dioxide when they dissolve in HNO3 they will convert into actually what? Pale yellow color. Actually nitrogen dioxide is having some color called brownish yellow color, brownish colored gas it is. So, because of the brownish color once dissolved in the HNO3 it will produce what here? Yellow color actually. So, reason will be simply because of dissolving of nitrogen dioxide, that is the one sentence you have to write actually. Next, what is fumic nitric acid? Fumic nitric acid is nothing but just simply what happens whenever NO2 when dissolved in the concentrated HNO3 that is called what? Fuming HNO3. Next, HNO3 is having some corrosion action. Whenever what some water is there on the surface of what the skin, on the skin, the water will be easily removed actually by what? HNO3. Because of this what happen, we are going to get the painful blisters. Next, we will see the structure of the HNO3 generally planar structure. If you observe here what happened, this will be in plane like this, nitrogen, 3 oxygens, and actually you have to write like this, you can write like this. This is a structure in which what happened, we can get here planar structure actually. So, this is about the some physical properties of what. Next, if you observe the chemical properties here, so it will exhibit some chemical properties. First one, if you observe here, it is acidic properties. Being as strong acid here, isn't it? It will release H plus ion. So, when you dissolve in the water, what happen? When you add some water, H plus ions are given to the water. It acts as a base. It acts as a acid actually. Release H plus to this one. So, because of this H2O convert into H3O plus, because of loss of H plus it will convert into NO3 minus. Next, important thing is that it is a strong oxidizing agent. Oxidizing agent means what actually? Undergoing reduction. If you undergo reduction, what happens? That is called oxidizing agent. Now, it will attack different types of metals except what happen? Noble metals. Noble metals generally does not react with HNO3, but they react with aqueous reagent, that is different. So, what type of metals they undergo? Let me see with the example called zinc and copper actually. Now, when you observe with the concentrated HNO3, the product we are going to get is nitrogen dioxide, NO2. Here also what happened? NO2. Common product will be what? NO2, water and water. And in the case of zinc, it will convert into zinc nitrate. NO3 is there, that will convert into nitrate. NO3 will convert into nitrate. So, in the case of concentrated HNO3, we don't get any problem to remember. Very simple, zinc nitrate, copper nitrate. Same products in both the case, nitrogen dioxide. But when you consider the dilute HNO3, isn't it? We get some lower oxidation product. You see here it is +4 oxidation state, here it is +4 oxidation state. But when you take dilute HNO3, we get lower oxidation state called nitrous oxide, N2O, and also what happened? Nitric oxide. Here in the case +2, in the case of this one +1. So, with zinc we get nitrous oxide, with the copper we get nitric oxide. So, very simple to remember here. So, whenever if you take what? Zinc, I will explain this one, isn't it, by taking something small diagram representation. Now, observe here what happened, zinc with dilute HNO3, what are the products we are getting? Zinc nitrate taken 2 times N2O plus water. In case of constant HNO3, again zinc nitrate plus nitrogen dioxide plus water. When you take copper, in the presence of dilute HNO3, copper nitrate taken 2 times nitric oxide plus water. constant HNO3 again same, copper nitrate plus NO2 plus water. Now when you observe here what happened, when you take constant HNO3, these are what common, and these are nitrates only. But when you take the dilute HNO3, the thing is different, N2O and NO, these are the different. Copper, nitric oxide, zinc, N2O. Isn't it? In this way we can easily remember the chemical reactions. Next, continuation, non-metals. How it reacts with non-metals let me see now. Iodine. Iodine, whenever react with nitric acid, it will convert into iodic acid. This is what actually iodic acid. Now, how to make balancing here? Very simple to balance. See here actually 0 oxidation state is there, iodine. Here it is oxidation state is what here? Plus 5. If you don't know, see here. Hydrogen always what? Plus 1. Iodine we are calculating, and each oxygen carries minus 2. See, one oxygen carries minus 2. There are 5 oxygens are there. Sorry, 3 oxygens are there. Now, iodine will get here what? Plus 5 oxidation state. Now, you see 0 to 5. How many electrons are going here? 5 electrons. From here to here, there are what? 5 electrons are going. But how many iodines are there here? 2 iodines. Put here 2. For one iodine, there will be 5 electrons, isn't it? 0 to plus 5 means loss of 5 electrons. Here, loss of what? 5 electrons. But actually, 2 iodines, 2 into 5 is equal to how many? 10 electrons you are losing here. Loss. Now, here HNO3, isn't it? Converting into NO2, this one. In the case of this one, again it is also same, plus 5. This one is plus 4. How many electrons? Only 1 electron. But how many are losing here? 10 electrons. But gaining how many? Only 1 electron. So, to balance this one, how many electrons we have to add here? 10. Isn't it? So, here 10 electrons we need, put here 10. Now, it is over. Next, when it reacts with carbon, we will get carbon. All the cases, remember, nitrogen dioxide, water is common in all cases. NO2 plus water is same in all cases here. The different products we are getting from iodine, iodic acid, carbon, carbon dioxide, sulfur, sulfuric acid, phosphorus, phosphoric acid, isn't it? So, how to balance? Again same thing, 0 oxidation state plus 4. So, how many electrons are losing here? 4 electrons. Therefore, you put here 4 here, completed. Next, here actually you take 0 only, oxygen state sulfur. Now, how many it is? Oxygen state will be plus 6 here. If you don't know, do like this, 2 hydrogens, 2 into plus 1. Sulfur we are calculating, and 4 into, each oxygen carries minus 2. Put here what? Minus 2 is equal to 0. Sulfur will get here plus 6 oxidation state. So, now how many here? 6. Put here what? 6 here. Next, phosphorus 0 oxidation state. Phosphoric acid will be plus 5 oxidation state, just like this one. Same method you have to follow for hydrogen plus 1, for oxygen minus 2 here. Now, but there are 4 actually. Now, 5 electrons, but there are 4 actually, multiply with 4, because 4 phosphorus are there, but each phosphorus losing 5 electrons, 5 4s are how many? 20. Put here 20, we get the 20 here. In this way, we can easily get this one 20, here also what? 20. 6, put here 6. Next, what? 4, put here 4, isn't it? 10, put here 10. Now, it is everything is balanced here. In this way, we are going to get some reactions with the non-metals. Next, we will see the brown ring test. This will useful for test for nitrates. For testing what? NO3 minus ions. Wherever NO3 minus ions are there, we can test that one, like KNO3, NaNO3, HNO3. Wherever NO3 is there, we can easily test by using which test? Brown ring test. Test for what? Nitrates. This one. Next, how to do this test? Take a test tube. Take the sample which contains any nitrate. Take something concentrated HNO3, anything which containing what? NO3 minus. To this freshly prepared ferrous sulfate, FeSO4 you have to add. Then add drop-wise concentrated sulfuric acid. After addition of this, we get a brown ring, isn't it? At interface of this, we get a brown ring here. The brown ring indicates the sample contains what? Nitrate ion. Now, in this case, what happening here? Ferrous sulfate. This is actually what? Fe plus 2, nothing but actually ferrous sulfate, FeSO4. I have taken only Fe plus 2. NO3 minus converting into nitric oxide here, and Fe plus 2 converting into Fe plus 3 here. Here balancing is also very simple here. How to give balancing? Actually oxidation state here plus 5, this one will be plus 2. Now how many electrons are here? Gained. Plus 5 converting into plus 2 is gaining of 3 electrons. So that is the reason, if it is gaining 3 electrons, multiply this one with 3, here also we get here 3, everything is balanced. Water is easily balanced. Once we get this one, everything will be balanced, because here 3 oxygens are there, here already 2 plus 1, the remaining will be easily balanced by taking out 6 moles of H plus. Balancing of water is very simple, that is no need to bother about this one. Balancing of NO3 minus is very important. After this, what happened? This Fe plus 3 and water, sorry, not this Fe plus 3, this Fe plus 2 again this Fe plus 2, I will take here Fe plus 2 again, I will take this from ferrous sulfate, will again react with whatever the water which is formed in this case. Now this will react with nitric oxide, so that we are going to get here what? Iron, lose one water molecule, this NO act as a ligand, enters into the complex compound. Because of entering the nitric oxide into this complex compound, we get brown ring, this one. This is the test for what? Nitrate actually.